was learning about Spark particularly, but then I looked into it, and the main language that people use for Spark development, I mean, the native language is Scala. Scala is something that I've used before, uh, not much, but I have had some time using Scala a little bit, and I used PySpark as well. I don't really see much difference, but then I was checking why there are like two options why people are opting either for Scala. I don't think a lot of people know about Scala, but a lot of people do know about PySpark. So uh, I was just exploring about that, but then stumbled into how structured data files are stored. So right now, yeah, right now I was just like looking into how PySpark files are stored. I've been asked this a couple of times, and I was never really interested to to look into this how files are stored, because if you have a parquet file, be it let's say if you're on a Windows or a Linux, you can't really see it in a default manner. Like if I have a CSV file, I can just double click it. So maybe it was like a barrier to entry. I don't know what to call it. Then I was never really interested to like actually explore and see how it is stored or data is stored internally. So yeah, I was just looking into that. The Parquet file is stored like this, uh, as opposed to relational databases, like not relational databases, basically like relational files, where you store every record in a row format. So you have a if you have data like ID name and ID name class, like if you have these three columns, so you will store, let's say you store 10 rows, you will store one row as ID1, name1, class1, then it'll be next iteration will be ID2, name2, class2. uh, but in Parquet, how you store data is you store all of the columns collectively. So all the columns will be stored at one location, not one location, but they'll be handled differently, and the other column data of the other column would be stored differently, not differently, but like individually. So yeah, that's how it is stored, and this is how a Parquet file looks on the top of it, like from a 50,000 feet kind of scenario, from top down approach. So you have columns, and then you have column metadata, and you have columns, then you have column metadata. So like for example, as I said, if you have ID name and class, so this would be ID would be your column, and then you would have some metadata for that, and then at the end you have file metadata. So that's all what was stored in this 5-minute video. I was kind of interested to see what exactly is he talking about. Like he does mention uh, like efficient data storage. So and he does mention encryption and encoding. So from there I was just interested to see how encoding is used. So this is what happens. Let's say you have this is your data set. This is what I've learned till now. This is your data set, I have my Alice Bob, and these are my data for city. So how it basically records is either it will create a dictionary encoding, or it will create a run length encoding, one of these, and then it will compress each column individually. Now this is column compression, this is not block compression. So it doesn't pick like couple of columns, it only picks one column for each compression iteration. So if you have data like Alice Bob, which changes a lot, like if you have data which changes a lot in occurrence, then it will probably use dictionary encoding, and it will say, okay, I have Alice and Bob, and it will create references for that in integer. So these are integer references, these are not bit references. It's not like 0 1 0 1 0, it's not like that. So it's only using 0 1 just because I only have this guy only has two entries. So you have like uh, whatever name, like Jensen, right? Jensen is the third word, so it would be like 0 1 0 2 1. So that's what it's trying to showcase. Now this metadata is stored only once, and then this data is encoded into the integer references. And for stuff like for data which is uh, continuous and does not change over time, like at least for some frequency. So let's say if you have 25 25 25 and then 32 32, 30 30 in this case. So then for that it creates a run length encoding, RLE. So this one is little like incorrect, as like how this is shown. This is little bit incorrect, classic GPT. But after this is done, so you have data either encode into dictionary or like an RLE, and then you compress all of it using Snappy, JZip, or like whatever compression algorithms you use. So yeah, that's what I've learned till here. I will download a couple of parquet files and try to run this in my VM and see. Yeah, for example, I wanted to see how this data could be visualized. Like if you have a CSV file, you can just double click it and see. Okay, there you have your data. Uh, but if you don't have that, so you have this thing called PyArrow. I'll look into it. Like I've not done it yet. I will install it. It's like a pip, like a Python package. I'll do that and see how the data looks. So yeah, that's it for today's video.